Now, today we are going to start with the type of waves and shock waves. Before going to the details of the types of waves, we start with the Mach number. Mach number is defined as a ratio of speed of the object to the speed of the sound in the given medium. That is, object speed divided by the speed of the sound in the medium. Whatever the speeds which we see, the vehicles moving on the earth will always be moving with a lesser speed when compared to the speed of the sound in the medium. Acoustic waves. An acoustic wave is simply a sound wave. It moves with the speed 333 meters per second in air at STP. Sound waves have frequencies between 20 Hz and 20,000 Hz. All the sound waves which we are able to hear with our human ear are sound waves lying between these frequencies. Next is ultrasonic waves. Ultrasonic waves are the pressure waves having frequencies beyond 20,000 Hz, and these ultrasonic waves travel with the same speed as that of the sound. These ultrasonic waves are having these frequencies more than 20,000 Hz, so these waves cannot be heard by the human beings. Only the dogs can detect these ultrasonic waves. Next is subsonic waves. If the speed of the mechanical wave or a body moving in a fluid is lesser than that of a sound, then such a speed is called as a subsonic and the wave is called as a subsonic waves. Here, as per the definition of the Mach number, if the speed of a body is moving with a lower speed than that of a speed of a sound, obviously the Mach number will be less than 1 as the numerator is less than the denominator. So the Mach number is less than 1. All the waves whose Mach number is less than 1 are called as a subsonic waves. The speeds of all the vehicles like car, train are nothing but a subsonic speeds. If you look at the figure given here, a bird is flying. Since the flight of a bird is slower compared to the speed of the sound waves are traveling at a higher speed and the bird is lagging behind in the figure. This means that the bird flight is a subsonic flight because the speed of the bird is less compared to the speed of the sound. Obviously, Mach number is less than 1. Next, coming to the supersonic waves. Supersonic waves are the mechanical waves which travel with speeds greater than that of a sound. That is, with speeds for which Mach number is greater than 1. For example, today's fighter flight planes can fly with a supersonic speed. Implies the speed of a fighter flight is very much high when compared to the speed of the sound. According to the definition of the Mach number, object speed divided by the speed of the sound in the medium. Since the object is moving with a very high speed compared to the speed of the sound, so the numerator value is more than the denominator. Mach number value is always greater than 1. Such type of waves are called as a supersonic waves. The fighter flight planes that moves with a very high speed, such flights are called as a supersonic flights. A body with supersonic speed zooms ahead by piercing its own sound curtain, leaving behind a series of expanding sound waves and their centers displaced continuously along its trajectory. Amplitude of supersonic waves will be high and it affects the medium in which it is traveling. If you look at the figure given below, here a jet is moving with a speed greater than that of a sound. Therefore, jet is leading and the sound waves are lagging behind, which this type of a flight is called as a supersonic flight, which you can able to see in the figure very clearly. The jet is moving at a higher speed and the sound waves are lagging behind. Next is hypersonic waves. They travel with the speeds for which Mach number is greater than or equal to 5. All the waves which are having the Mach number greater than or equal to 5 are called as a hypersonic waves. Next is transonic waves. These are the speed range which overlap on the subsonic and supersonic ranges. We say it is a transonic range for which the Mach speeds, that means the Mach number should be greater than 0.8 and should be less than 1.2. Such speeds are called as a transonic speeds or the transonic waves. Now it is called as a gray area where there is overlapping of some of the characteristics of the both subsonic and supersonic speeds. If you, as defined before, all the waves having Mach number less than 1 are called as a subsonic, and the Mach number greater than 1 are called as a supersonic. Here transonic is an overlapping between 0.8 and 1.2. So it has both, it is overlapping both the subsonic as well as supersonic waves. So it has some of the characteristics of both subsonic as well as a supersonic speeds. Next is a Mach angle. A number of common tangents drawn to expanding sound waves emitted from a body, a supersonic speed, formulate a cone called as a Mach cone. The angle made by the tangent with the axis of the cone, that is half the angle of the cone, is called as a Mach angle mu. Mu is related to the Mach number m by the equation mu is equal to sine inverse of 1 by m. Next, we start with the shock waves. Shock waves are not an electric shock waves what you think or imagine. A shock wave is different from an electric shock wave or whatever the shock you are able to imagine. A shock, any fluid that propagates at supersonic speeds gives rise to a shock wave. That is a fluid which is moving very high speed. That is, the speed of the fluid should be greater than the speed of the sound. So such a fluid can propagate a shock waves. Shock waves can be produced by the sudden dissipation of mechanical energy in a medium enclosed in a small space. Shock wave, how the shock wave is produced is that there should be a sudden dissipation of mechanical energy in the medium enclosed in a small space. Shock waves are characterized by sudden increase in the pressure and the density of the gas through which it propagates. The moment a shock wave is being generated, there will be a sudden increase in the pressure and the density of the gas through which it propagates. Usually when the shock wave is being created, there will be a sensors which detects the temperature and the pressure, from which you can say that there is a huge increase in the pressure and the density of the gas. Shock waves are identified as strong or weak depending upon the magnitude of the instantaneous changes in the pressure and the temperature in the medium of a space bound within the thickness of the shock front is of order of few micrometers. So the strength of a shock wave, whether it is strong or weak, is depending upon the pressure and the temperature rise in the medium within which a shock front is of order of few micrometers. A shock wave created by explosion of crackers are the weak. That means a cracker gives a huge sound for a small instant of time. This shock waves which you feel there is a sudden increase in the sound, which are nothing but a weak shock waves. A shock wave created during the lightning, thunder are the strong. When you see during the lightning thunder, the lightning comes first, then you can hear a booming sound. That is because the velocity of light is more compared to the velocity of sound. What is the velocity of light? 3 into 10 to the power of 8 meters per second. But whereas velocity of sound is 330 meters per second. So since there is a huge variation in the speeds during the thunder lightnings, you can see the lightning first and then you can hear the booming sound. Such shock waves are the strong shock waves. Now shock waves produced during nuclear explosion are the strongest. You can see the difference here, what is a weak, what is a strong, and what is the strongest. Whatever the waves produced during the nuclear explosion are strongest. This type of weak, strong and strongest are characterized by their Mach number. So it is the Mach number that determines the types of waves and also determines what is in which category this falls under, the wave falls under. We have seen a variety of types of waves: sound waves, that is acoustic waves, ultrasonic waves, hypersonic wave, transonic waves, subsonic waves and supersonic waves, and finally we came with the shock waves. Thank you.